Hi there. Good morning, afternoon, or evening, depending on where you are joining us from today. Welcome to our webinar, No Shadow, No Secret. Firstly, thank you for your joining us today. Over the next hour, we will be diving deep into the world of malware analysis, specifically focusing on how modern threats try to hide and how advanced analysis platforms can uncover their secrets. So the title of webinar, No Shadow, No Secret, reflects our goal to shine a light on evasive malware techniques and demonstrates how we can achieve comprehensive analysis without blind spots. So in this webinar, we will explore techniques and also we will in touch what's our platform do different from the others. So let's look our agenda. And in this session, our goal is provide a clear picture of challenges in malware analysis and how ThreatZone addresses them. First, we will tackle sandbox versus sandboxes. The term sandbox is used widely, but not all sandboxes are created equal. We will break down into the different types, their strengths, weakness, and use cases. And after that, we will dive into the core challenge about anti-VM, sandbox, and analysis techniques. How malware author using these techniques hide them from the analysis process. And then we will introduce our holistic platform, ThreatZone, and the philosophy behind the holistic approach. Before the deep dive into the content, let's introduce ourselves and company. My name is Kaan. I'm the co-founder and CEO of Malvation. We founded Malvation 5 years ago in Istanbul. There is a sub-branch in USA. We are a member of AMTSO, the Anti-Malware Testing Standard Organization Group. And also we have two products. The first and the main focus is today, ThreatZone, our holistic analysis platform. We also have a product named HookMesh. It's a threat incident and analysis automation platform. And at the below, you can see our technological and sales partners. The cybersecurity market is big, and we believe collaboration is a key in this market. So we work closely with leading technology providers, resellers, and distributors across the globe to deliver our solution effectively. The ecosystem helps us to provide better, more integrated security outcomes for our clients. So you know a bit about us, and let's get into our first topic, sandbox versus sandboxes. So the simple question is simple. Are all sandboxes the same? When you're exploring sandbox solution at the market, there's a lot of sandbox solution. When you try to purchase from firewall, they say we have a sandbox. When you try to purchase sandbox for incident response, there's a lot of options. And some cases, the sales guys actually use the wide term and getting confused. So firstly, we need to declare each sandbox are same or not. What's the difference? To help clarify this, we can refer to the framework into the AMTSO, the Sandbox Evaluation Framework. This framework provides a useful way to categorize sandboxes based on their primary function. So let's look at these type of the sandboxes. The first type is inline protection. Think of this integrated into your email gateway, your web proxies, load balancer, web gateways. Their focus is real-time threat interception. They need extremely low latency because they can't hold up whole traffic, right? This means their analysis depth is often limited, and they are great for catching known threats. But they can easily bypass by more sophisticated and unknown malware, because they need to require in-depth analysis for that, but they don't have a time to meanwhile analyzing whole traffic at the same time. So the second type is dynamic threat triage. These sandboxes offer a balance between speed and depth. Latency is low to moderate, and the analysis depth is moderate to high. And they often integrate with CM, SOAR, EDR, XDR solution because they mainly used on the alarm verification process. For example, you have an alarm in your EDR, there is some suspicious file or a malware alert, and you can use these type sandboxes to validate is it really or not. And third one is threat intelligence. The sandboxes can be used for create threat intelligence and generation. And in the focus shifts to the in-depth behavioral analysis and understanding the full attack chain. Because there is a no latency concern, we can give more execution time for sandboxes, and we can get more data from sandbox results, and we can integrate this data to the threat intelligence platform, and it can be used for tasks like tracing threat actors, extracting indicators, attributing attacks to specific adversaries, or mapping behavior like micro-attack matrice or some taxi server. And the final and the most comprehensive sandbox type is forensic analysis sandboxes. These offer highest level depth and are often used as a standalone tools. Latency can be high. Their purpose is a deep investigation, and it's mainly designed for the level 3 or advanced incident response teams to advanced threat research, analyzing highly malware evasion tactics, or mapping complex and multi-stage attack chains. So ThreatZone operates primarily in the threat intelligence and forensic analysis space, offering deep insights, but with feature designed to also support efficient triage to the type of sandbox cascades. It's effective against different kinds of threats, and it's actually bypass malware evasion techniques and help to do your efficient workflow. So before the practical session, we need to understand what's the anti-VM sandbox techniques, why it's important to bypass them, and is really enough to use common techniques to test our sandbox solution. So why it's important to bypass techniques? Actually, it's a simple question. If malware detects analysis, it will often alter its behavior. It can be hide from your sandbox or analysis process. Maybe it can display fake benign activity or even try to crash your analysis environments. It depends on the malware, it depends on the technique, doesn't matter. If your sandbox can't bypass these techniques, these checks, you can see malware's true actions, leading to the false negatives, and it's create a critical gap in your defense. You might think it's safe. When it's approve this file in your network, they can crash your whole ecosystem. And other cool questions arise. Are tools like Puffish and Alcazar good enough to test malware sandboxes? Actually, these are well-known open source tools, and specifically, they execute known detection techniques checks in your environment. They check, is it a known virtual machine? Is there a hypervisor? Or they check hypervisor artifacts like their agents or their drivers. They can check debugger, or they can execute some timing attack. It's a cool techniques, but common ideas they use common techniques that can be used by malware. They are useful benchmarks for identifying a common weakness in sandboxes. However, relying solely on them can be misleading, because sophisticated malware often use newer and unpublished or combined techniques that these tools don't cover. Furthermore, as we'll see later, some checks these tools perform can be unreliable. So while passing Puffish Alcazar is a good starting point, but it's not the whole story. The final question is, every detection method is logical, and why we use anti-VM, is it really necessary? Why we use anti-sandbox, it will be help to the malware author to increase their chance to exploit company. So let's deep dive into the ethical dilemma, the trolley problem actually. It illustrates the problem in our malware analysis market. In this problem, there is actually two options. You can choose two outcomes. Here's your sandbox solution, this operator of lever, and there's a malware bus is heading towards a detection point to the wall. And the sandbox has a two choice. You can pull the lever or don't pull the lever. If you decide it's a malware, yes, you can block malware in here. But if you can't understand it's a malicious file, you just messed up whole operation, you just messed up whole automation in your workflow, and you can crash all your clean system or your IT ecosystem. And so it's create a problem. It's a false negative, actually. So this is the first outcome of the problem. If your sandbox is not good enough to detect and bypass evasion techniques, you can get misleading, and you can make wrong decision, and it can create a really problematically end of the day. So the other outcome is, the complexity actually is really different in the problem. If the sandbox detection mechanism is too aggressive, so if it say everything to the malware, and you can create a false positive now. So you can say every clean file as a malware, and it's another problem in our ecosystem. So this is the one part. And the other part is handcrafted techniques. Puffish, Alcacer, and some other tools give us a really rich area to use anti-analysis techniques and sandbox techniques. But in real life, the things happen different. So as you can see in the screenshot, the first one is coming from Joe Sandbox, the other one is from Enron. The sandbox solutions try to create user-friendly products for their user space. Meanwhile, some features can be used by malware author to detect their sandbox environment. For example, Joe using some OCR agents, some clients for accessing sharing clipboard. But in virtual machine, you can clearly see their agents. So malware can use them to detect directly Joe. So in Enron, their kernel driver expose their debugging log into the debug view. They don't try to hide them from the attackers. But as you can see, if you open debug view on Enron VM, you can see which dump process function called which time. So these artifacts can be used a malware developer for handcrafted techniques. This is the other face of our sector. So the last question is every anti-analysis method logical? And what's the keep it simple? So let's start with keep it simple story. When we say malware authors often keep it simple, it doesn't necessarily mean simple in the sense of checking the username, disk size, or classical techniques like we mentioned in the Puffish and Alcacer. Although those checks still exist, malware authors simply refers to technically straightforward but highly effective low-level checks that target the fundamental difference between physical hardware and virtualized environment. These are often harder to spoof than high-level configuration. And at this point, I like this example very much, actually. The example is scientific MSRs. MSRs means model-specific registers. They are special control register in x86 architecture. And some hypervisor explore and use these MSRs registers to use their in purpose. For example, Hyper-V and VMware use these synthetic MSRs for their guest host agents. So if malware can attempt to read non-synthetic MSRs using its simple instruction, it's actually RDMSR instruction. If the read succeeds without causing any exception, it's a very strong indicator that code is running under the specific hypervisor. It's crucial, in Alcacer, in Puffish, there is some user mode techniques can help to understand is it a VM or not. But with kind of niche techniques, you can specifically understand which hypervisor running at the environment. So it can be help to understand is it a commercial hypervisor or specifically designed for the sandbox environment? It's also a hard question, but it gives another perspective in that. But end of the day, checking virtual machine are not necessary for the malware, because in current situation, we run all things in cloud, in VM. So if a malware specifically try to detect virtual machine as a malware purposes, it will be less the chance to execute in specific critical session. So it's not logical in my case. So also there's a project called name Malware Scarecrow. It's actually using this approach invert that. It creates specific artifacts on physical machine that can be mislead detection for anti-VM and anti-sandboxes. And so if you install in your computer, the physical machine look like virtual machine. So skid malware use kind of techniques, you can bypass them. So let's get main focus on the question. What's the threat zone? We discussed the challenges, we understand what type of sandboxes and what's the sophisticated evasion techniques, and here's our solution, threat zone. We define threat zone as a holistic malware analysis platform. So the common question is, what does it mean, the holistic? With holistic keyword, it's mean we aim to provide comprehensive end-to-end solution that covers multiple features of malware analysis. It's not just about running a sample in a virtual machine. It's about deep, dynamic, and stat analysis across various operating systems, static analysis, and integrate the data to your whole other product for threat intelligence and other actionable product in your environment. So our goal is provide to no shadow, no secret capability, ensuring that you get full picture of what malware does, unobstructed by evasion techniques. It's designed to explore, catch, and analyze threats effectively. So let's dive into some key features. At Threat Zone, the first and important option is deployment options. We offer Threat Zone as a public cloud. You can access here app.threat.zone. There is a freemium, and if you are a researcher, you can contact us and create your free account here. And we're giving this service as a public cloud. We can also host for you in isolated environment as a private cloud. Also, we provide this product without any feature cut at your own infrastructure as on-premise. Also, we describe Threat Zone as a rooftop platform for advanced malware analysis process. This signifies that it's a high-level comprehensive system that integrates various analysis capabilities under one roof. For example, you are a SOC analyst and you need a lot of tool in incident response process. At Threat Zone, we try to provide whole technology in under one roof. So it's important. And the most crucial feature is Threat Zone supports multi-OS analysis for dynamic analysis process. So that means we can detonate file in Windows, macOS, Linux, and Android. And after presentation, we will make a live demo and show nearly how Threat Zone do that. And finally, and the most important feature, and it's a cornerstone feature actually, our platform is a stealth, and we can do whole analysis under the radar. So this directly addresses the anti-analysis techniques actually we discussed earlier. Threat Zone engineered from the ground up to minimize its footprint and avoid common and complex detection vectors used by malware. We don't just react to the known checks, we proactively design whole environment to be difficultly to identify as a sandbox. So we developed our own custom hypervisor patches to do that. I will touch in later. So how Threat Zone different from others? Because there is a lot of sandbox at the market, so we need to declare which features are different from others and what's our strong points at the market. The major differentiator is our tailor-made hypervisor actually. It's specifically designed for the advanced use cases like malware analysis. And many sandboxes on the market rely on the actually on the off-the-shelf hypervisor, like VirtualBox, VMware, QEMU, KVM. These are powerful hypervisor, general-purpose hypervisor, but they have known artifacts and behavior that malware can detect them, like specific hardware IDs, I/O ports, and some specific actually agents installed onto the hypervisor. So our custom hypervisor is built with stealth as a primary goal, minimizing these detectable artifacts and allowing us to implement unique features for deeper analysis and control. This is fundamental to our stat analysis capability, actually. Beyond the core execution environment, ThreatZone focuses on providing advanced features specifically for designed SOC teams and incident responders. So here, I can talk about some advanced features. The first one is golden image support. You know, malware, especially targeted attacks, might only run correctly configured system from your company. Maybe there's some pre-installed software. Maybe they can check some Active Directory domain. So at ThreatZone, users can upload their own golden image to the environment, and they can use this image in analysis process. There's some custom proxy and VPN feature for Dirty Line. You can configure threat analysis machines to route their network traffic with your proxies and VPN. And we also have a residential proxy network and some advanced feature, and we will touch in the live demo. So the main question is, can ThreatZone really smash these techniques? We discussed these techniques and we talked about them. Talk is one thing, but proof is essential. In the next slides, we will show how ThreatZone smash these techniques and more complex them, and what's the build different thing from the others. So, bypass traditional. Here we see the output of Puffish, Paranoid Fish, one of the standard tools that we mentioned before. And it's basically check some common things in the virtual machine. They check mouse speed, they check debuggers, and it look some VirtualBox, VMware, or camera detection methods like that. And as you can see, there's some problem in here. Generally in POCs, the most people look at this space. And yes, we trace. So this is actually problematically thinking here. This techniques relies on the idea that executing certain instruction, especially those might cause VM exit into the hypervisor level. So if its interaction caused VM exit, it takes a lot of time compared to the real CPU, and we can detect, yes, it's a virtual machine, but is it really reliable? So when we look at the GitHub issue reports and some insight of the source code, as you can see, these techniques or some other techniques can be unreliable because the real environment, real hardware can be play different. For example, if you install Hyper-V into your laptop, you can trace by these techniques because Hyper-V change some things or enable some feature into your CPU, and it can affect the frequency or some hardware implementation, and it can be mislead to the you. So using specific techniques like that can create confusion for the detection part. So this is the traced part of our engine. And let's bypass traditional. As you can see, if we open Regedit in ThreatZone virtual machine, we can see the BIOS information like from real computer. You can see this whole information like copied from the real hardware. So it's just developer note. Bypassing traditional is really simple. Because these common techniques using user mode checks. So if you if you have a knowledge about developing a hypervisor or developing sandboxes, you can bypass as easy pie. However, bypassing these simple techniques and not enough to create a realistic sandbox environment, right? So let's push the limits because we need advanced challenges. What about the technique designed to stress analysis environment, exploit timeouts, or look some different indicators in here? In the next section, we will explore how ThreatZone tackles more sophisticated evasion tactics, such as sleep attacks and hardware emulation checks, and we will compare ThreatZone and other sandboxes. So, bypass sleep attacks. Actually, this is the most simple and effective anti-analysis techniques in the internet. You know, you can just call sleep API with 10 minutes, and most sandboxes has a specific short timeout because you know, if you deploy sandbox in your environment, you need to analyze a lot of file in a per day. So you cannot make analysis for a 1 hour or 2 hour. It's too long. So you need to set a timeout. But if you set a timeout, malware can use to hide them from your analysis environment. So for example, think again, a malware sleep itself 10 minutes for, so your sandbox has a 5 minutes timeout. Basically, you cannot understand what's malware doing after the 5 minutes. So in here, we will examine the compare with other sandbox and ThreatZone. As you can see in the screen, we just execute Alcacer with some timing checks at any run. And in the first techniques, the set timer, we need to wait 10 minutes to run other techniques. So it's failed. When we look at triage, as you can see, it's still stuck on the set timer function. So we need to wait 10 minutes, but the other techniques we will wait another 10 minutes, another 10 minutes. So there is no end for that. So it's again failed. But at ThreatZone, as you can see, it's a normal speed. We don't need wait for 10 minutes because ThreatZone engine actually identifies when malware attempts to call these sleep techniques, and it's manipulates their arguments in the memory and CPU. So instead of waiting 10 minutes, ThreatZone automatically speed up this process and manipulate them and trigger real malware behavior. So with that, actually, we can bypass malware techniques, malware that use this sleep function in their execution line. So the another and cool part is hardware emulation. You know, if we use a physical laptop or computer, we use physical hardware connected to our device, like our SSDs, our microphone, camera, and even our GPU or CPU fan. So in here, as you can see, wait a minute, I will zoom in. If we try to check our CPU fan in triage or any run, we get nothing. That means there is no CPU fan hardware in the environment. So with that, you can understand it's obviously a virtual machine. But in ThreatZone, we can also emulate this hardware in our sandbox environment. So if you execute this VMI command in ThreatZone, you can just get a prop device of our cooling device, and you can see there's a CPU fan. Also, it has a fake speed and cooling information like that. So this is the first part of how we can bypass complex techniques that malware can be used. The another one is I really like this page actually. You know, in Puffish Alcacer we use user mode environments, user mode checks to detect sandbox and virtual machines. But sometimes the keep it simple philosophy actually help to the malware developer, because in common sandbox, in common virtual machine, if you see your device manager, if you open USB with tool like that, you can see some hit compliant mouse, or you can see some standard FGA adapter. But at ThreatZone, as I mentioned in the start, our aim is bring the most realistic sandbox to the market. So in ThreatZone, as you can see, if we open the USB view, as you can see, there's some real USB and keyboard brands. Also, we can emulate real graphic card signature in here. Like there's a connected NVIDIA GTX mobile version. Also in USB device tree viewer, you can see some physical connected emulator in here. So this is another part of the ThreatZone feature. Also, we mentioned we have a residential proxy network. So that means in the ThreatZone virtual machines, there is no signature for proxy and data center IP address, because geotargeting is important for malware analysis. Some malware actually designed to do only active in specific region or countries. Also, IP reputation, another part of our job, right? If IP belongs to the Amazon or Microsoft Azure, you can understand it's coming from some cloud provider, and maybe might be used by a sandbox provider, so you can block that. But at ThreatZone, our all network connected to the residential proxies. So as you can see, if you with this page, we bypass all actually mobile and proxy and hosting checks. So it's like coming from the home computer. Also with our proxy and VPN configuration, custom configuration, we can create another line into your network. And the best part is, I said we design hypervisor to complex use cases. So, some sandboxes try to bypass uptime feature. They just create specific snapshots after the 10 or 20 minutes, and they use this snapshot specifically. But at ThreatZone, we maintain the hypervisor patches, we manage whole complex techniques, and as you can see, when malware, when a virtual machine running, we can easily change a whole hard-coded environment things in here. For example, in this video, as you can see, we change uptime increasingly by the by. And wait a minute. So we talked in theory, we talked in isolation technique, and we demonstrate them. But we need to look at a case study in real life. So I will open these links in my browser. After that, I will do a live demo, and we will see why bypassing malware evasion techniques are crucial for our analysis process. Because if we don't bypass these techniques, we can get misled. We can get real IOC of malware. So first, I will show the comparison on original logger sample. And after that, I will show our platform in live demo. And after, we will do a Q&A session. So I need to stop my screen and reshare. I think you can see the screen now. Okay, good. Okay, we mentioned there is a sample. It's actually origin logger, the after agent Tesla sample. And I will show the results in triage, AnyRun, and threat zone, and we will see why bypassing this technique is crucial. So at triage, we get malicious indicator. It's good for us to detect it's a malware. When we look signature, it said it's a malicious because they detect some PowerShell script modify Windows Defender settings like that. When we look process tree, there's a some PowerShell execution. It's open Chrome to bypass their credential protect system. It's a cheap thing. And at the network, we just see some beacon address that Chrome used when runtime. So there is a no specific family name. There is a no specific C2 address. Just normal things happen while open your browser. So when we open AnyRun, we got a suspicious level. And as you can see, there is also no specific indicate for the family name and anything about it's a malware or not. When we look at HTTP requests, it just some noisy data from the other process, like some background process. So these are noisy data, it's unnecessary. There's no connection to the some C2 address, or there's a no trace data. So when we do same analysis at threat zone, as you can see, we get it's a malicious. And when we look at indicators, our ERA scanner detect it's a agent test sample from the memory dumps. Because this sample, it's a two-stage loader. It's loads another part into the runtime session. So our engine collects memory dump while runtime, and we can match its agent testa from that. Also, we see it's launch some scheduled task and other things. So at in the overview part, we easily detect it's a agent testa sample. When we look network parts, unlike the others, we see the Telegram C2 address because Origin Logger push their collected data into the Telegram bot. So as you can see, we see which request, actually which address requested by suspicious file, malicious file, and what's the URL, what's the other stuff like that. So as you can see, if Sandbox can't bypass anti-analysis techniques, they failed. You can't get real IOC, you can't get real information about the sample. So this is the in real life actually consequences of the why it's too important to bypass these techniques. So let's make a live demo about our platform and what's the other capability of the threat zone. So this is our cloud platform. As I mentioned, you can just access app.threat.zone and create your free account. Also, if you are a student or individual researcher and want to use higher level plans, just contact with us. We can provide a higher plan. So at threat zone, you just actually basically need to upload your sample to the here. After that, the platform want to get some configuration from your side. What's that? We have a three scan type, dynamic scan, static scan, and some symbolic execution emulators. And in dynamic scan configuration, as we mentioned, we support macOS, Android, Linux, and Windows. And there's some execution duration for a specific timeout. And also, we have some smart tracing feature. It's context-based analysis. And you can enable bypass, slip evasion, or not. And also, we have a memory dump and file dump connector. So that means if it's a two-stage loader and it downloads things from the C2 server, we can file dump and do other stuff. Also, we can decrypt HTTPS traffic as well. So also, we have an advanced network configuration. I will be in touch that. After launch submission, our engine platform gets a file from your side and creates and allocates a free VM in our farm, and we will show a VNC screen while analysis ongoing. As you can see, you can connect to the virtual machine, and you can use your keyboard and mouse and manage a whole analysis process. That's the first part of the dynamic analysis part. So I will go on with the already actually finished sample. There's a, as you can see in the sample, we have a first part in the dynamic scan. There's some table and region. In the media, we provide whole session records while analysis ongoing. And in the indicator, we provide which things happen into the behavior sites, what that's mean, what's their score. As you can see, there's some YARA match, AV detection batch. Also, we have an integration with what is engine, and we show their results in page here. And you can see all other behavior stuff like that. So it's actually generic and common parts because Sandbox need to show them. But if you need more in-depth details, we have also syscall feature. So as you can see, there is a indicator said it's suspiciously launched under program. So if you click see in syscalls, we show which syscall happened into the virtual machine and what's the arguments, what's the other data. So it help to the rush engineer, help to the level 3 incident responder because it's give a really rich data to you. Also, you can see whole process flow, whole process tree, and whole behavior data and other syscalls. And if there is a network events, as we showed other samples, you see the whole data like that. So if there's a threats, we have a signature matcher here. We use Suricata rules, and you can see whole matched Suricata rules in here. What's the source destination address, which packet matched with this rule. So in here, I will show our first interactive feature, the web Wireshark. You know, most sandboxes provide a kind of feature like that. But if you need to examine the pickup file in your environment, you need to download pickup. You need to open in your computer with Wireshark or other tools. But remember, at the beginning, I said our aim is bring a holistic approach. So we don't want to leave ThreatZone platform to do another tool. We try to provide whole technology under the one. So you don't need to download pickup file. Just click the Wireshark, and as normal Wireshark, in the web Wireshark, you can see whole packets, whole details, and whole data. And you can just click them, and you can see all the information. That's easy. In the static scan, we show statically our micro engine, what they do in the file, some file info. If there's a malicious strings, we show them. If there's a matched YARA rules, we also show them here. And these options are actually automation part, right? Yes, we understand it's malicious file. Yes, we understand we need to block them. But in the response part, ThreatZone need to help incident responders. So generally in SOC automation process, if we see it's a malicious, we need to write YARA rules, we need to write some Sigma rules to check in our environment. So ThreatZone help to do here right now. In the hunting page, we create some auto-generated YARA rules to detect this sample and similar to these threats. And let's check out is the error rule really work for that. You can download error rule, and after that, we need to drag and drop in here. So also, I will load to the sample. So after I click to the execute, as you can see, our auto-generated error rule successfully detect this sample. So you can use this error rule in your forensic tools to detect in your whole environment, in your file system, in your FTP servers, like that. And the last feature is crime scene investigation. It's coming from TV series. And, sandbox give us whole rich data. It's okay. But in some complex cases, we need more information. So we need to set up our test environment. We need to install our tools. We need to download artifacts from sandbox, or we need to recreate them into our analysis environment like memory dump, file dump. So our approach is a little different in here. As I said, we don't want to leave the threat zone. We want to do all this job into the environment. So if you need to export your memory dump or file dump, you can click the export submission and you can download the HTML report, you can download the file dump and memory dump. And if you need to examine them into your isolated environment, you don't need to set up your environment. Just click Start CSI session. It's automatically create isolated Linux environment that's coming with some pre-installed tools. At on-prem installation, we can customize with your toolset. Also, we give all data in here. For example, you can see the original sample. You can see the whole memory dump that's captured from our engine, and you can use Yara Radar to recall FQ volatility into this terminal. For example, I need to decompile main function of this sample. I just open it with Yara Radar 2. Make analysis. Let's switch to the visualized mode. Click the function and show the compiler. As you can see, in a seconds, I can easily explore all capabilities of Radar 2 in the browser. That's all. So I need to reshare my presentation again. Yes. And actually, the whole demo parts and whole presentation, it's finished here. Now we have a time for Q&A. If you have any question about the presentation, the demo, the threat zone, or malware in general, please type in chat or Q&A screen, and I will do my best for answer that. And also my team they will answer. And thank you for all joining to the webinar, and you can answer the questions. Ulaş Fırat Özdemir'in bir sorusu varmış. Okay, let's look at this question again. If ThreatZone is manipulating sleep function calls, can't malware check system time before and after the sleep and see it was faster than supposed time? Actually, we have some edge cases in sleep bypassing sleep evasion tactics, but also we have some accelerator for that. For example, if sample specifically use system time to check is it speeded or not, we can bypass as well. But in some cases, malware just don't wait into the client side. They wait response from the C2, so we can't bypass kind of techniques because the author need to enable the second stage in the command and control center. But if malware basically just check system time and just sleep native function, we can accelerate them. But as if you need to be honest, these are actually a catch game. We develop new bypass techniques and malware author develop new escape techniques. So there's a no end, there's a no fully ready solutions. That's all. And Franjal has a question. Can we take memory dump from the sandbox when a set of specific functions is called? Actually, this is one of advanced use cases at some on-premise customer. For example, they're using this custom hypervisor and engine for reverse engineering specific cases. We support kind of feature in our internal engine and SDK. So yes. Mehmet has a question. Check network drivers and disk capacity. This kind of TTPs works on ThreatZone. Actually, we, as I said, we bypass this kind of traditional checks before malware it happen. For disk size, there is a huge disk connected to the virtual machine. Also, the drivers and the other components of the in hardware based are copied from the real environment. Ulash has another question. Since we could import a golden image and the platform manipulates the shown hardware, can we specify rules for that? Actually, we have a agentless approach, so we didn't and don't install any agent into the Windows images. So if you provide a golden image, we convert to the R format, and after that we do analysis. So I think, I guess, there will no problem for that. Mert has a question, Q&A tab. Do you use TLSH for static analysis, or it's based on SH, SHA, and MD5 only? Actually, I need to check in the static analysis page. Also, you can visit a platform and check on yourself. And some anonymous attendee ask why it's important to use as a use a sandbox in a security infrastructure. It's starts the sandbox terminology starts coming from the 20 or 25 years ago. The approach is simple. Before incident happen, we can create a matrix for malware, and we can watch what it do in the simulated environment. So if we want to create a complex and robust security architecture, we need to put all kind of sandboxes into the architecture, because some customers, some users mix the terminology inside of the sandbox, as I said at beginning. There's a lot of different type of sandboxes, so you need to choose in your purposes, you need to choose on your actually use cases. So for example, you are an enterprise and you has a more than 1,000 employees, and there's a specific big budget for the cybersecurity, and you need to create intelligence inside of your operation and your team. So for that, you need to create holistic approach, like I mentioned in the presentation. It's important because you don't have a chance to miss malware like context that we mentioned. The another question is, it's only used standalone or can be integrated to SOAR, EDR, etc. Actually, there's a two option. You can use a standalone workbench in your research team. Also, we have some native integration with protocols and products. You can use our SOAR integration in your SOAR. Also, we have another product called Hook Mesh, and with that Hook Mesh, we can integrate with ICAP, SFTP, and other products. So there's a seamless integration. I think we finish the whole time, and there's another question. Can we change the base image running in the sandbox environment, aka golden image? Yes, we mentioned in the very beginning presentation. Okay, I think that's all. Thanks for your all question and joining us today. I hope it's enjoyable webinar event for you. If you have another question, you can contact us from email and website or another social media channels. Thanks again. See you later.